Good afternoon. Today is the week 30 of the live interactive session, Introduction to Atmospheric and Space Sciences. Today is the last class, so I will be mostly introducing you some concepts that's already been discussed in your NPTEL class, and we will mostly focus on solving different problems related to these concepts. So first I will start with so we have been discussing about ionosphere, what are its peculiarities, different layers in the ionosphere, and we also learned how to find the production of electrons or ions in the ionosphere at a particular solar zenith angle and height, and also we also derived equation for the peak production and peak production height in the ionosphere. Now let us consider if an electric field of the plasma or the ionosphere is interacting with an external electric field, how the particles may behave. So first we will consider a uniform electric field. So we will be discussing the particle motion in a uniform electric field. Particle motion in a uniform electric field. So consider that the electric field is uniform and static. Uniform and static. Uniform in the sense, static in the sense it is not changing with respect to time. d by dt is equal to 0. And uniform in the sense it is not changing with respect to space. d by dz is equal to 0. Now consider the electric field. So let this be your x, y and z direction. This is x, this is x, this is y. This is x, this is y, and this is z direction. A particle is approaching towards the field with a charge q and mass m. It has a charge q and mass m. And the direction of the electric field is this. The electric field is acting along the z direction. The electric field is static and uniform. Ez is a constant. And there is no field component along the x and y axis. Ez is constant with respect to z and time. And there is no magnetic field that is acting in the there is no active magnetic field in this case. So if we consider the total, so generally in the presence of an electric or magnetic field, the total force experienced by a charged particle is given by F is equal to Q into E plus V cross B. So this is known as the Lorentz force, which is a force acting on a charged particle in the presence of an electric and magnetic field. So in this case, only B is 0. The force is basically Q. So I am not going detailed into derivation. This is a Lorentz force acting on the particle, and if the velocity of the particle is given by Vxi plus Vyj plus Vz. So the initial velocity of the particles before applying the magnetic field, electric field is given by Vx is equal to Vx0, Vy is equal to Vy0, and Vz equal to Vz0. And when it experiences an electrical or when it interacts interacts with the electric field, after interacting, the particles interact after interacting with the electric field. After interacting with the electric field, the velocity of the particles become Vx will be Vx0 itself, Vy will be Vy0, and Vz will become Vz0 plus Q by M into Ez into A. So this is the so the Vz will have a Z component like this, whereas in the x and y direction, velocity in the case of x direction, the velocity will be same after the particle experiences the electric field as the initial velocity. In Vy also it will be equal to the initial velocity. Whereas in case of the z axis, the initial velocity plus the term which is linear in nature will be added in case of the z direction. So in this case, this term is linearly increasing with respect to time. Vz is linearly increasing as the time goes. So the motion of the particle along x and y will not be affected by the electric field. So consider that the now the particle. So we just stole some charged particle and we have given the given it as q. Now consider that the particle is positively charged. Consider q is positive. In that case, the direction of motion will be Vz will be Vz0 plus Q by M Ez into T. So it will be moving along the direction of the electric field. The particle will be moving by this is Z. This is the direction of Ez. Right? So when Q is positive, the particle will be moving along the direction of the electric field, positive Z direction. Whereas in case of negative, when Q is negative, it will be Vz0 minus Q by M Ez into T. It will be moving in the opposite direction. So the ions will move like this and the electrons will move like this. Case of ions. So the ions will move in the along with the direction of the electric field, whereas the electrons will move away from the electric field. So both two types of particles are present enter into the electric field. All positively charged particles move like this and all negatively charged particles move like this. So before entering the field, the plasma, the charges were not separated in the plasma. But after entering the electric field, the plasma particles will be separated because the electrons and ions starts moving differently. So it is basically creating a charge separation. The electric field is creating a charge separation within the plasma. The ions will move in the direction of the electric field, whereas the electrons will move in the opposite direction. And if we look at the total energy that is experienced by the particle, it is given by half mv square plus q phi, where half mv square is the kinetic energy, which is by virtue of the mass and velocity, and q phi is the potential energy, which is due to the charge and electric field of the particle. This will be found to be a constant. The total energy of the particles will be conserved, but it will start moving. The ions will start moving along the direction of the electric field, whereas the electrons will start moving in the opposite direction. So the important inferences that can be derived are: first one, the particle velocity, which is given by Vz, is changing, is linearly changing with respect to change. It is not change. It is not, the electric field is not affecting the velocity along the x and y direction. Particle velocity is linearly changing with respect to time. This is one thing. The second thing, the total energy, which is basically the sum of kinetic energy plus potential energy is conserved, and the total energy is conserved. These are the two important assumptions considering the particle motion in a uniform electric field. And the work done will be zero. Since the total energy is constant, the work done will be zero. Now the second case, so this was uniform electric field. Now consider particle motion in a uniform static magnetic field. Consider the particle motion in a uniform static magnetic field. So in this case, E is equal to 0. Dou B by dou T. Since it's static, is equal to 0. And dou B by dou Z is also 0 because it is uniform. It is homogeneous in space as well as time. A particle of charge Q and mass M is experiencing a particular field B, but is also acting along the Z direction. Please consider that this is also acting along the Z direction. This X, Y, and Z. So in this case, we look at the Lorentz force, which is given by Q into E plus V cross B. The force that is acting on the particle will be F is equal to Q into V. This will be the force that will be acting on the particle. So F is perpendicular to the direction of V and B. The direction of F will be such that it will be since it is cross product, it will be perpendicular to the direction of V and B. Now if we solve this, we will get that the different components of the velocity, we will get it as Vx is equal to Vx0 cos omega t plus Vy0 sin omega t, and along the y direction Vy is given by minus Vx0 sin omega t plus Vy0 cos omega t, and Vz will be Vz0. So this will be the different components of the velocity Vx, Vy, and Vz. We will find the trajectory of the particle. So we saw that in case of electric field, in the case of a uniform electric field, it was moving. The electrons were moving in the opposite direction of the electric field, whereas the ions were moving in the same direction as the electric field. So in this case, let's see how the particle is actually moving in the magnetic field due to the effect of the magnetic field. We will square and add dx square and dy square to find the trajectory of the particle. So these are the different components of velocities. Now to find the trajectory of the particle, to get the trajectory of the particle, we will square and add dx square and dy square. So dx square will become dx0 square cos square omega t plus dy0 square sin square omega t plus 2 v square dx square, it is in the form a plus b the whole square. So vx square cos square omega t plus vy0 square sin square omega t plus 2 dx0 vy0 cos omega t into sin omega t plus 2 vx0 vy0 into sin omega t into cos omega t. And y square will become dx0 square sin square omega t plus dy0 square cos square omega t plus 2 dx0 vy0 sin omega t into cos omega. Now we add dx square plus vy square. It will become, so this and this if we add sin square omega t plus cos square omega t is equal to 1. So it will become vx0 square plus vx0 square. Here also it will be vy0 square plus in this case this will also be 1. So in this case vx0 square is common, in this case vy0 square is common. This will be minus. This is minus because this is minus vx0 sin omega. This term will be negative. So this and this term will be cancelled out. And finally, if we add, we will get vx square plus vy square is equal to vx0 square plus vy0 square. This corresponds to the equation of a circle. So basically, the magnetic field is creating a circular motion in the xy plane. And we know Vz is constant. So because of Vz, the angular, this is moving like this. The particle will be moving like this in a helical motion. It will be moving like this. So it is creating a circle in the xy plane, and also it is having a constant velocity along the Vz zero. So the particle will have that circular motion. And because of the non-zero component of the velocity along the z direction, the particle is pushed in the positive z axis. So that's why we are getting a helical motion like this. Now if you want to find the radius of the circular motion, it is given by RL is equal to mv perpendicular by q into. And if you want to find this is the radius of, this is not the radius of gyration, that is the radius of the cycle that the magnetic field, the circle that the magnetic field is creating around the xy plane. So this is not the radius of gyration. And if you want to know the angular frequency of these oscillations, it is given by qb by n. And the frequency of oscillation is given by omega by 2 pi or qb by 2 pi. So radius of gyration, angular frequency. cyclotron frequency. This frequency with which the particle is moving along the z direction by creating a circle in the xy floatron frequency. Floatron frequency is given by qb by 2 pi, and the point, the radius is known as radius of the circle is known as radius of gyration, and the frequency is known as the cyclotron frequency. And the center point, or the point around which the circular motion is executed, axis along center, point around which the circular motion is executed is known as a guiding center. And in case of an ion, it will always drift or will always revolve to the left. If we are considering an ion, the direction of gyration, or it will always drift to the left, which means it will be like this. And in case of an electron, it will be towards the right. So it will be like this, towards the right. And since the electrons, the mass of ions is greater than the mass of electrons, according to the radius of gyration, which is given by mv perpendicular by qb, perpendicular with respect to the direction of magnetic field. So since it is dependent on m, and the mass of ions is greater than me, RL in case of ions will be greater than RL in case of electrons. It will be, in case of ions, it will be creating larger circles compared to that of an electron. In that case, it will be smaller. So in case of an electron and ion, one thing, there will be change in the direction of this gyration. In case of ions, it will be towards the left, and in case of electron, it will be towards the right. And also, the radius of gyration will also be different in case of electrons and ions, since it is dependent on the mass, and since mass of ions is very much greater than the mass of electrons, the radius of gyration in case of ions will be greater than the radius of gyration in case of electrons. So in this case, the major conclusions are so in this case also, we are considering the particle motion a uniform magnetic. If the particle is experiencing a homogeneous static magnetic field, then energy is conserved. No work is done. And the particle's trajectory will be in circular in perpendicular direction. In this case, since the magnetic field is acting along the z direction, the circular motion was in the xy plane, in the perpendicular direction, and linear in the parallel direction. This is the z direction, linear in parallel direction, where we got Vz is equal to Vz. And in case of an ion, the drift will be towards the left, and in case of an electron, will be towards the right. The direction of gyration is called Lamar's precision. That's about the particle motion and a uniform magnetic field. Now let's consider the particle motion when we are applying perpendicular electric and magnetic field. In case of in the presence of perpendicular electric and magnetic fields. Particle motion in case of perpendicular electric and magnetic fields. So let us consider the electric field. This is X, this is Y, and this is Z. Let us consider that the electric field is present in the XZ plane. XZ plane, electric field will be like this. And the magnetic field is acting along the Z direction. It will be like this. So E is basically a function of X and Z, and B is a function of B. In this case, Ey will be 0. In this case, Bx is equal to 0. By is equal to. In this case, the force that will be acting on the particle will be Q into E plus E cross B. Both electric and magnetic field is there. E plus E cross B. In this case, the velocity components will be Vz is equal to Q by M EZt plus Vz0, and Vx will be V perpendicular into E raised to I omega c into t, where omega c is given by Qb by T. So that's cyclotron frequency. Vy will be plus or minus I V perpendicular E raised to I omega c t minus Ex by. So this parameter Ex by B, this is known as a drift velocity. So these are the three different components of velocity in this case. And what are the major conclusions from this, the major inferences from this case? First one, Vz depends only on Z, only on Ez. As we can see, Vz Q by M Ezt plus Vz, it only depends on the electric field. So Vz is changing linearly with respect to time. Vz is changing linearly with respect to time. And second one, Vx and Vy, neither of them are linear in time. Vx and Vy, neither of them are linear in time. And the circular motion is still preserved in Vx and Vy. If you find the trajectory along the x and y direction, it will still be circular. And in addition to the circular motion, we have an additional component in addition to the circular motion, an additional component, the drift velocity Ex by B is also coming. Ex by B is coming in Vy. So Vx and Vy are making the particle execute circular motion, but this circular motion is superimposed by another component of velocity, which is Ex by V. This is known as the drift velocity. And this superimposed velocity is called as the drift of the guiding centers. Like it will be moving away from the guiding center as it keeps on, as it executes the circular motion, it will keep on moving away from the guiding center. That is the drift velocity. Yeah. So that is in case of the particle in presence of perpendicular electric and magnetic field. Now let us try to solve some problems related to these concepts. So the first question, calculate the radius of gyration of proton with kinetic energy (15 mega electron volt) and magnetic field (0.35 Gauss). Mass of the proton is given as 1.67 into 10 raised to minus 27 kilogram. Answer is, so we basically want to calculate the radius of gyration RL equal to question mark. Things that are being given in the question is kinetic energy is given, which is 15 mega electron volt. It means 15 into 10 raised to 6, and 1 electron volt is 1.6 into 10 raised to minus 90 joule. Magnetic field B is given, which is given in Gauss, 0.35 Gauss. To convert it into Tesla, SI unit, it will be 0.35 into 10 raised to minus 4 Tesla. Now, the equation for the radius of gyration RL is given by mv by q. We know the mass, we know q since it is a proton, V we know, but we don't know what is the velocity. But kinetic energy is given. So kinetic energy is basically half m v square. It's just given as 15 into 10 raised to 6 into 1.6 into 10 raised to minus 9. From this we can calculate the value of V. So V will be 2 into kinetic energy to 6 into 1.6 into 10 raised to minus 90 divided by mass, which is 1.67 into 10 raised to minus 27. It is given in the question. Whole root. It will come around 2 into 1.5 into 10 raised to 6 into 1.6 into 10 raised to minus 90. It will come around 4.8 into 10 raised to minus 13 divided by 1.67 into 10 raised to minus 27. It will give you 2.87 into 10 raised to 14. Now if you find the whole root of 2.87 into 10 raised to 14. It will give you 1.6 into 10 raised to 7. 1.69 into 10 raised to 7 meter per second. 1.69 into 10 raised to 7 meter per second. Now to find the radius of gyration RL, we'll substitute RL is equal to mv by qb. M is 1.67 into 10 raised to minus 27 into velocity we got as 1.69 into 10 raised to 7. 1.69 into 10 raised to 7 divided by Q is 1.6 into 10 raised to minus 19 into B is 0.35 into 10 raised to minus 4. The answer will be 1.67 into 10 raised to minus 27 into 1.69 into 10 raised to 7. It will give you 2.82 into 10 raised to minus 20 divided by 1.6 into 10 raised to minus 19 into 0.35 into 10 raised to minus 4. The final answer should be 15.98 into 10 raised to 3 meter. We'll check the value of velocity once more. So 1.69 into 10 raised to 7. RL is mass into velocity by Q into B. 1.6 into 10 raised to minus 19 into 0.35 into 10 raised to minus 4. Is giving a value of around 15.98 into 10 raised to 4. And you work out the problem once by yourself and make sure the answer is correct. I would have done some lost the connection in between. The final answer is coming to be 15.98 into 10 raised to 3. Just check once by yourself if it is correct or not. The second question. If the radius of gyration is 200 meters, what is the kinetic energy of the electron when moving in a magnetic field of 0.5 into 10 raised to minus 4 Tesla. So given RL is equal to 200 meters, which means we know RL is given by MV by QB. mv by qb is 200 meter. We want to find the kinetic energy of electron. Kinetic energy half mv square is equal to question mark. D is given as 0.5 into 10 raised to minus 4. We need to find the kinetic energy. Kinetic energy is half mv square, or we can write velocity is equal to root of 2 into kinetic energy by m. So if we substitute it over here, the velocity we will substitute RL will become mass into root of 2 kinetic energy by m by qb. So this m and this m will become, so it will be root of 2 into kinetic energy into m divided by q into b, or we can write qb into RL is equal to root of 2 kinetic energy into m. To qb RL by root of 2m is equal to root of kinetic energy, or kinetic energy is equal to the whole square of this. Kinetic energy is equal to q square b square RL square by 2 into m. This is the equation for kinetic energy. So kinetic energy will be, the value of q is 1.6 into 10 raised to minus 19, since it's an electron. The value of b is given in the question, which is 0.5 into 10 raised to minus 4. And RL is also given in the question, which is 200 meter divided by 2 into mass. Mass of an electron is given by 9.11 into 10 raised to minus 13. So if you will find the answer, it will be 0.6 into 10 raised to minus 19 square into 0.5 into 10 raised to minus 4 square into 200 square divided by 2 into 9.11 into 10 raised to minus 31. It will be 1.405 into 10 raised to minus 12. It is 1.405 into 10 raised to minus 12 joule. This will be the answer, 1.405 into 10 raised to minus 12. If you want to convert it into electron volt, in terms of electron volt, 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. So its electron volt is equal to 1.405 into 10 raised to minus 12 joule. X is equal to 1.405 into 10 raised to minus 12 joule divided by 1.6 into 10 raised to minus 19. It will be 0.405 8.78 mega electron volt. In terms of electron volt, it will be 8.78 mega electron. This is the kinetic energy of the electron. Now, the third question. What will be the ratio of radius of gyration of proton to electron? What will be the ratio of radius of gyration of proton to electron if velocities and magnetic field are same for a proton and electron. What will be the radius of gyration of proton and electron if velocities and magnetic fields are same for a proton and electron? So we know RL is given by mv by qv. So let's write that radius of gyration in case of an electron is mass of electron into velocity of electron into q into v. Q will be same in case of electron and proton, we already know. And in case of proton, it will be mass of proton into velocity of proton by q into v. Okay, so in the question it is given mv, if velocities and magnetic fields are same, which means mv is equal to vp and ve is equal to the magnetic field associated with both the proton and electron are also same. The velocities are also same. So RL E by RL P will be ME by MP, proton to electron. So the other way around, RL of proton by RL of electron will be mass of proton by mass of electron. These are known values. Mass of proton as 1 point, because everything else will be gone from the equation. Finally, it will be mass of proton by BP. VE and VP are same as given. This is also same. Q is same, we already know that. So it will be ME by MP in case of electron by proton. In case of proton by electron, it will be MP by ME. So 1.67 into 10 raised to minus 27 is the mass of a proton, and 9.11 into 10 raised to minus 31 is the mass of an electron. So the ratio will be 175 or 1.7 into 10 raised to 3. This will be the ratio of proton to the radius of gyration of proton to radius of gyration of an electron. Or we can say the radius of gyration of proton is 1.7 into 10 raised to 3 times the radius of gyration of an electron. Because both the velocities and the, if we are applying the same magnetic field and the velocity of proton and electron are the same, this will be the next question. Consider an alpha particle uniform magnetic field zero point 0.05 Tesla and having cyclotron angular frequency of 2.39 into 10 raised to 6 radian per second. What is its mass? Consider an alpha particle in a uniform magnetic field of 0.05 Tesla and cyclotron frequency omega is given as 2.39 into 10 raised to 6 radian per second. Magnetic field is given as 0.05 Tesla. Charge of alpha is basically 2 into charge of an electron. So it will be 2 into 1.6 into 10 raised to minus 19. Mass we have to calculate. Mass will be so omega c or the cyclotron frequency is given by qv by m, which is equal to 2 into 1.6 into 10 raised to minus 19 into 0.05 divided by m, or we know the value of omega c, or we can write m is equal to 2 into 1.6 into 10 raised to minus 19 into 0.05 divided by omega c, which will be 2.39 which will be 2.39 into 10 raised to 6. So it will give you 2 into 1.6 into 10 raised to minus 19 into 0.05 divided by 2.39 into 10 raised to 6. It will be 6.69 into 10 raised to minus 27 kilogram. Mass of alpha is the alpha particle 6.69 into 10 raised to minus 27 kilograms. This is the mass of the alpha particle. Next question. What is the charge to mass ratio of electron use that value to compute the angular frequency if the magnetic field is 0.004. What is the charge to mass ratio of electrons? QE by ME. QE by ME. We know the charge of an electron is 1.6 into 10 raised to minus 19. Mass of an electron is 9.11 into 10 raised to minus 31. the ratio of QE by ME will give you will be 1.756 into 10 raised to 11 coulomb per kilogram. 1.756 into 10 raised to 11 coulomb per kilogram. This is the charge to mass ratio of an electron. Now calculate the angular frequency omega c of the magnetic field is 0.04 Tesla. Magnetic field is given 0.004 Tesla. Now the angular frequency omega c is given by QB by M. QEB. So QE by ME we know is 1.756 into 10 raised to 11, and the magnetic field is given as 0.004. So the answer will be 7.025 into 10 raised to 8 radian per second. 7.024 into 10 raised to 8 radians per second. Next question. The radius of gyration for an electron of kinetic energy ten mega electron volt in Earth's magnetic field is 0.45 into 10 raised to minus 4 Tesla. Will be, so you want to find the radius of gyration for an electron of kinetic energy 10 mega electron volt, which means 10 into 10 raised to 6 into 1.6 into 10 raised to minus 19. Magnetic field is given as 0.45 into 10 raised to minus 4 Tesla. What will be the value of RL? So we know kinetic energy is half mv square. From this we can calculate the value of V. Since it's an electron, we know what is the value of M and what is the value of Q. To calculate RL, we need QB by M. We know what is Q and what is M. M radius of gyration is given by mv by q. The other one was angular frequency. mv by qb, we know what is m. We need v. Q and b are given. Q also we know. We need, v is given in the question. We need to calculate v. So v is not given directly, but kinetic energy is given. From this we can calculate q v as 2 kinetic energy by mass, root of 2 into kinetic energy by mass. So RL can be written as root of 2 kinetic energy by mass into QB into M by QB, or we can write root of 2M into kinetic energy divided by M was given as 9.11 into 10 raised to minus 31 kilogram. Q was given as 1.6 into 10 raised to minus 19 coulomb. RL will be root of 2 into 9.11 into 10 raised to minus 31 into mass is 9.2 m into kinetic energy by QB, right? Kinetic energy, mass is 9.11 into 10 raised to minus 31 and kinetic energy is given as 10 into kinetic energy is given as 10 into 10 raised to 6 into 1.6 into 10 raised to minus 19 divided by 2m kinetic energy divided by 1.6 into 10 raised to minus 19 Q into B. B is 0.45 into 10 raised to minus 4. The answer will be root of 2 into 9.11 into 10 raised to minus 31 into 10 into 10 raised to 6 into 1.6 into 10 raised to minus 19 divided by 1.6 into 10 raised to minus 19 into 0.45 into 10 raised to minus 4. The answer will be 237 meter. 237. This will be the radius of gyration of the electron and the given conditions. Now let us, I'll just revise two more concepts that you would have already learned, and then we will solve a couple of questions. So next one we will be learning about the gradient shift. The particle motion in the presence of a varying magnetic field. Often the magnetic field in plasma varies with position or time. It is not always homogeneous, so it generally varies. So there will be an inhomogeneous magnetic field causing the plasma particles to drift. So since we are considering that the magnetic field B is varying with respect to space, especially along the y direction. We have been looking at how the plasma will be affected by various different types of magnetic and electric field. While considering a uniform electric field which is static in nature, we found that the particle will be accelerating along the direction of the electric field. In case of the magnetic field which was homogeneous, that is uniform with respect to space and time, we found that the particle will execute a simple circular motion if there is no additional component of velocity which is parallel to the magnetic field. Now, if there is a component of velocity which is parallel to the magnetic field, the particle will move in a helical path. And the particle velocity which is parallel will not be influenced by the magnetic field. In the case that we considered, it was Bz. So along the z, the velocity was not changing. It was Vz is equal to Vz0 itself. Whereas in the xy plane, it was executing a circular motion. Now, when we combine these two uniform electric and magnetic field, we consider perpendicular and electric, the particle motion, and the presence of perpendicular electric and magnetic fields as well. In that case, we found that a charged particle with a mass m and charge q, when experiencing particular electric and magnetic field, it will experience that the guiding center drift, which we called as the drift velocity. We got it as Ex by v. Now let us consider an inhomogeneity in terms of space or in time. Suppose the field is changing as the particle is moving. If the magnitude of the field is changing in time as the particle is moving, it is basically known as inhomogeneous. So it means that at each and every point as the particle moves, it experiences different magnitudes of field. We will introduce inhomogeneity to the picture by introducing length or scale of inhomogeneity. This is the distance after which, so we are basically considering an inhomogeneous magnetic field. We are considering an inhomogeneous magnetic field. Inhomogeneous magnetic field. So, and we are introducing a scale of inhomogeneity, which is L. So this is the distance after which the magnetic field becomes inhomogeneous. So if R less than L, then the magnetic field is homogeneous. And if R is greater than L, then the magnetic field will be inhomogeneous. So let us say that the direction of magnetic field is in the positive z direction. So this is x, y, and z. This is x, this is y, and this is z. Suppose this is the direction of the magnetic field, which is bz, and this is the direction of the change in magnetic field, which is del. Positive. Let us consider the gradient of the magnetic field is in the y direction. So the direction of the magnetic field is in the positive z direction, and the gradient of the magnetic field is in the y direction. So B is given by, along the x and y axis it is 0, and it is acting along the z direction and varying along the y direction. So how does it, so we consider this is del B. So the magnetic field lines will be far from each other in case of smaller values of y, and as we move up, it will become more closer together. So closer magnetic field lines indicate stronger magnetic. So it will be like this. In case of a homogeneous magnetic field, we know that the particle experiences a force Q into V cross B. In this case, if we find the velocity components, we will get the drift velocity. I am not going in detail to the derivation. The drift velocity that will be forming due to the change in the magnetic field along the y direction is given by V del B is equal to minus V perpendicular RL by 2BZ into dou BZ by dou BZ by dou Y, since it is changing along the y direction. And the direction of the movement of the particles will be along the I direction or along the H direction. So here due to this drift that is happening here, what happens is that the helical motion that was caused due to the uniform magnetic field that we saw here. Earlier when we looked at the helical motion, it was along the y direction. Now this will be along the x direction. And in case of electrons, the drift will be like this. In the positive x direction, whereas in case of ions, it will be in the negative x direction. So this is in case of electrons and this is in case of ions. Earlier when we were considering a homogeneous magnetic field, the helical motion was along the y direction, and only change between electrons and ions was that in case of electrons it was the direction of gyration was towards the right, and in case of electrons it was towards the left. But in this case there is a charge separation that is happening. That is, the electrons are moving in the positive x direction, whereas the ions are moving in the negative x direction. So this charge separation leads to what is basically known as planetary ring currents. And the drift velocity due to the inhomogeneous magnetic field is given by plus or minus v perpendicular RL by 2bz into rho b by rho 1, which is acting along the I direction. This is drift velocity. Now, when we are considering the magnetic field lines associated with the Earth, the magnetic field always converge and diverge. The magnetic field lines converge and diverge at the poles. Suppose that we are considering the magnetic field. When we are considering the Earth, the magnetic field lines converge at the poles and diverge at the equator. These are the poles, north and south poles. The magnetic field as well. The magnetic field lines are curved like this. It is having a curvature. It is not straight. The magnetic field lines are not straight. Instead, it is having this curvature nature. So, because of this curved nature of the magnetic field lines, there is another drift which is known as a curvature drift. So, magnetic field lines are always curved and are always associated with a gradient and curvature of the magnetic field lines. The magnetic field lines, there is always a gradient because it is the magnetic field lines are closer at the poles and it is diverging along the equator, which means this energy, the field strength will be stronger at the poles and it will be lower at the, it will be lesser at the equator. So because of this, so one thing is magnetic field lines are curved. We are considering the magnetic field associated with the Earth. The magnetic field lines are curved and they are always associated with a gradient. Always associated with a gradient. So because of this, because of the gradient, what will happen? We saw there will be this gradient drift velocity. Now, because of the curvature, there will be another velocity which is known as a curvature, another drift velocity which is known as a curvature drift velocity, and it is given by. So now we have both gradient and curvature. The gradient drift velocity is given by m v perpendicular square by 2q into dou v by dou y. Now due to the curvature, the velocity that is, the drift velocity that is coming is given by 1 by q into mv parallel square by rc square v square into rc cross. This thing in a more generalized form. In this case, we are considering that the magnetic field is acting along the z direction and the gradient is along the y direction. In a more generalized form, we are not assuming these directions to the magnetic field. We can write mv perpendicular to by 2q into v cross del v. So this will show you the direction of the magnetic field, and this is the direction in which it is changed. It can be anything. It is not always along the z and y. It can be anything. So this is a more generalized form of the drift velocity, gradient drift velocity, and this is a generalized form of the curvature drift velocity. So this the gradient drift velocity is coming due to the inhomogeneous nature of the magnetic field, and the radial curvature drift velocity is coming due to the curvature nature of the magnetic field. Now let us try to solve some problems related to this. This is curvature drift velocity. This is the gradient drift velocity. First question, calculate the drift velocity at y equal to 3 into 10 raised to 6 meter if magnetic field varies as B equal to A by Y, where A is 2 into 10 raised to 4 Tesla per meter, and the kinetic energy of a proton in the magnetic field is about 2 electron volt. Calculate the drift velocity at y is equal to 3 into 10 raised to 6 meter. The magnetic field varies as B is equal to A by Y. Magnetic field is varying along the y direction. A is given as 2 into 10 raised to 4 Tesla per meter. Kinetic energy is given as 2 electron volt, which is 2 into 1.6 into 10 raised to minus 9 joule. We need to calculate drift velocity, which is V del, which is given as m v perpendicular square by 2 q v square into dou b by dou y. Have we learned? Or we wrote V del B is equal to mv perpendicular square by and this B perpendicular, it is V perpendicular RL by 2 dz. V perpendicular RL by 2 bz into dou b by dou y. This is a generalized form. Generalized form, it comes mv perpendicular by 2q into b cross del b by bq. Here in this case, yeah. So here we will use the simplified form. It's just B perpendicular RL by 2BZ into dou BZ by dou Y is equal to, we know what is the value of RL. RL is given by MV perpendicular by QB. If we substitute the value of RL, it will become MV perpendicular square by 2QB Z square into dou B by dou Y. Here this term half mv, this is half mv square, which is a kinetic energy. It is given, and Q, we know what is Q. Since it is a proton, the value of B is given A by Y, dou B by dou Y we can calculate. So if we substitute, it will become B del B is equal to kinetic energy by QB square into dou B by dou Y. Kinetic energy we know. B is given by A by Y. So dou B by dou Y will become minus A by Y square. If we differentiate it, it will become minus A by Y square, which will be minus 2 into 10 raised to 4 by Y is given 3 into 10 raised to 6 the whole square. Right? If Y is also given in the question, calculate, yeah, at Y is equal to 3 into 10 raised to 6. So Y is also given, so we can calculate the dou B by dou Y as minus 2 into 10 raised to 4 by 3 into 10 raised to 6 the whole square. How much it will be? 3 into 10 raised to 6 square. It will be minus 2.22 into 10 raised to minus 9. Minus 2.22 into 10 raised to 9. Minus 2.22 into 10 raised to 9. 10 raised to minus 9. Yeah. And B square will be A by Y square. A is 2 into 10 raised to 4 divided by 3 into 10 raised to 6 the whole square, which will be 4 by 9 into 10 raised to minus 4. 4 by 9 will be 0.44 into 10 raised to minus 4. So we know the value of dou B by dou Y, and we know the value of B square. Kinetic energy is given, QB no. So B del B will be the drift velocity. Gradient drift velocity is given as 2 into 1.6 into 10 raised to minus 19 into 2.22 dou B by dou Y, 2.22 into how much we got? Minus 2.22 into 10 raised to minus 9. 2.22 into 10 raised to minus 9 divided by d square, which is 0.44 into 10 raised to minus 4 into q, which is 1.6 into 10 raised to minus 19. The answer will be 2 into 1.6 into 10 raised to minus 19 into 2.22 into 10 raised to minus 9 divided by 0.44 into 10 raised to minus 4 into 1.6 into 10 raised to minus 19. The answer will be around 1 into 10 raised to minus 4 or 10 raised to minus 4. This will be the gradient of velocity. There is a negative over here. So minus 10 raised to minus 4 meter per second will be the answer. Now let's look at another problem which is related to the curvature drift velocity. So the question is, the kinetic energy of a proton in the direction of the magnetic field is 3 electron volt. The curvature radius is 4 into 10 raised to 6 meter, which is perpendicular to P equal to 1 Tesla. Find the curvature drift. Find the curvature drift. Kinetic energy is given 3 into 1.6 into 10 raised to minus 19 joule. RC, or the curvature radius, is given as 4 into 10 raised to 6 meter. And the magnetic field is given as 1 Tesla. We have to find the curvature V. dr. dr is given by 1 by q mv parallel square by rc square v square into rc cross. Here kinetic energy is given, so just multiply and divide. So it will be 2 kinetic energy, 2 into kinetic energy by q rc square v square into rc cross v. So kinetic energy is given, rc is given, v is also given, and rc cross v will be sine. It is shown that the curvature radius curvature radius is 4 into 10 raised to 6, which is perpendicular to v, which means the angle between them is 90 degree. So rc cross v will be rc v sine theta. Theta is 90. Theta is 90. So it will become 2 into kinetic energy by Q RC square B square into RC B sin 90. What is the value of sin 90? Sin 90 is 1. So it will become 2 into kinetic energy divided by Q RC into B. This will go. So 2 kinetic energy by RC into Q RC B. So if we substitute, it will be 2 into 3.3 into 1.6 into 10 raised to minus 19 divided by 1.6 into 10 raised to minus 9, which is Q, into 4 into 10 raised to 6, which is RC. B is 1. It will become 2 into 3 into 1.6 into 10 raised to minus 90 divided by 1.6 into 10 raised to minus 90 into 4 into 10 raised to 6. The answer will be 1.5 into 10 raised to minus 6 meter per second. This will be the answer. And the next question. If the magnetic field and moment of a particle is 0.5 Tesla and 8 into 10 raised to minus 19 joule per Tesla, what will be the angle between the velocity and magnetic field if its kinetic energy is A 2.5 electron volt and B 2.5 mega electron volt. The magnetic field, which is B, is given by 0.5 Tesla, and the magnetic moment, which is given by mu. Magnetic moment is basically m B perpendicular square by Q B perpendicular square by 2B, or kinetic energy by B. Mu is given by mv square mv perpendicular square by 2B. This is magnetic moment. It is given by 8 into 10 raised to minus 19 joule per Tesla. What will be the angle between the velocity and magnetic field if its kinetic energy is 2.5 electron volt and 2.5 mega electron volt? This is coming from the portion magnetic mirroring. You would have learned in your NPTEL class the concept of magnetic mirroring. Magnetic field has the ability to keep the magnetic moment conserved. So a charged particle that can be trapped within a magnetic field. The basic idea is that the magnetic field has the ability to keep the magnetic moment conserved. Condition for the plasma in a magnetic field, for the particles to get reflected or trapped or to be lost. here it is given the angle between the velocity and the magnetic field of the kinetic energy is 2.5 electron and 2.5 mega electron. So this is the direction of B. This is the direction of B parallel, and this is the direction of actual direction of B. This is B parallel and will be B perpendicular as well. This is theta. What will be the angle between? We have to find theta basically. The kinetic energy is 2.5 electron volt and 2.5 mega electron. So mu is given, B is equal to 0.5 Tesla. So the conservation of this magnetic moment gives you the equation mu by kinetic energy is equal to sine square theta by. So from this, we can write mu as mv square sine square theta by 2. So this is V. This is V perpendicular. Then V perpendicular is V sine theta. So we can write V perpendicular square as mv square sine square theta by 2. Or we can write mu. So this is kinetic energy. So mu is equal to kinetic energy into sine square theta divided by V. Or we can write mu by kinetic energy is equal to sine square theta by. We have to find theta. So we know what is mu, what is kinetic energy, V is also given. So from this equation we can find the value of theta. So sine theta is given by root of mu V by kinetic energy. Mu, the value of mu is given as 8 into 10 raised to minus 90 into V is 0.5 divided by 2.5 into 1.6 into 10 raised to minus 90. It will give you 8 into 10 raised to minus 90 into 0.5 divided by 2.5 into 1.6 into 10 raised to minus 90. It will give you a value of 1. Sin theta is equal to 1, which means theta is equal to 90. So V is acting perpendicular to the direction of the magnetic field. That's what it basically shows. Now the next question. If the magnetic field two cases are there here. In the first case, the kinetic energy is 2.5 electron volt, and in the second case, the kinetic energy is 2.5 mega electron volt. We only did for the first case. So in the second case, so for B, when kinetic energy is 2.5 mega electron volt, which is 10 raised to 6 into 1.6 into 10 raised to minus 90. In that case, sin theta will be root of 8 into 10 raised to 19 into 0.5 divided by 2.5 into 10 raised to 6 into 1.6 into 10 raised to minus 90. In this case, the value of theta will be 10 raised to minus 3. theta is very small. That is the second case. Next question. Calculate the magnetic moment of a particle in the magnetic field of 0.8 Tesla and kinetic energy of 3 electron volt and its angle is 30 degrees. Mu is given as sin square theta into kinetic energy by which is sin square of 30 degree into kinetic energy is given as 3 electron volt, which is 1.6 into 10 raised to minus 19 divided by B is 0.8. The answer will be sin square 30 into 3 into 1.6 into 10 raised to minus 19 divided by 0.8. The answer will be 1.5 into 10 raised to minus 19 joule per Tesla. Next question. Last question. Find the Lama's radius, which is the same as the radius of gyration that we learned. Radius of an alpha particle if the kinetic energy electron volt in magnetic field of 0.4 Tesla. So Lama's radius is the radius of gyration. RL is given by mv by qb, or 2 kinetic energy into m by qb. Kinetic energy is given as 12 electron volt. D is given as kinetic energy is given as 12 electron volt, which is 12 into 1.6 into 10 raised to minus 19 joule. Magnetic field B is given as 0.4 Tesla. Find the Lama's radius is a question. So RL will be root of 2 into 12 into 1.6 into 10 raised to minus 19 into m, which is 6.64 into raised to minus 27 divided by Q is 1.6 into 10 raised to minus 90 into B 0.4. So the answer will be, you calculate 2 into 12 into 1.6 into 10 raised to minus 90 into 6.64 into 10 raised to minus 27 divided by 1.6 into 10 raised to minus 19 into 0.4. Answer will be 2.49 into 10 raised to minus 3. 2.49 into 10 raised to minus 3 meter, or we can write 0.24 centimeter. This is the answer for the radius of vibration. This was the last problem. So we will wind up the session. This was the last class. All the best for your exams.